everyone. In this session, we will be learning how to draw graphs of trigonometric functions. In particular, we will be learning graphs of y equal to sin x and y equal to cos x. Now, where have you seen graphs before? Even in our normal life, we see graphs, like even in cricket matches. Now, when two countries are playing and for comparison graphs are used, you are able to see after how many overs, how many runs were scored by one country, which country is behind, which country is going ahead. Like this kind of conclusions you are able to make with help of graph. So graph is surely a nice tool to understand things better, since it's in picture form also, so it remains in memory also for longer time. So graphs has its own like benefits. Like, why do we draw graph? So whatever story we had done with help of unit circle, that same story now we try to put in form of graph. Now one thing about that unit circle was that we studied two coordinates x and y, and x stands for cos theta, y stands for sin theta. So as theta changes, how x coordinate and y coordinates change means how cos theta and sin theta change. This together study with help, when theta changes, this was on unit circle, means you are concentrating on cos theta and sin theta simultaneously when theta changes. Now instead of going for two things simultaneously, if you want to do one thing at a time, then concentrate on x coordinate only if you want to study cos theta, and concentrate on y coordinate only if you want to study sin theta. This is the purpose of drawing graph of y equal to sin x also. Now just recall what we had done on this unit circle. We have actually seen on arc AB, what happens that theta changes from 0 to pi by 2, right? And sin theta changes from 0 to 1, means y coordinate changes from 0 to 1. So if you move on arc AB, theta increases from 0 to pi by 2, and sin theta also increases from 0 to 1. Now I'm deliberately saying sin theta instead of saying y coordinate. Now what happens if you move on arc BA dash? Now when you are moving on arc BA dash, theta increases from pi by 2 to pi, and y coordinate now from 1 to 0 it comes. That means it decreases, right? So sin theta decreases from 1 to 0. Now, when you are on arc A dash B dash, now your theta will increase from pi to 3 pi by 2, correct? And your y coordinate, means sin theta, will now go from 0 to -1. Now, in this portion, your y coordinate goes from 0 to this -1. Okay. Now, when you move further from B dash to A, now your theta moves from 3 pi by 2 to 2 pi, means it increases. And then what happens to y coordinate? It actually changes from -1 to 0, means it increases, right? This is only about the first circle when theta changes from 0 to 2 pi. Now theta could have gone further also beyond 2 pi, or had you moved in clockwise direction, then theta could have taken negative values also. Now tell me, is it advisable to sit and make this large table like this for various values of theta and sin theta? Obviously not. Now this is what actually tells us that we should go for graph of y equal to sin x. Now this notation y equal to sin x perhaps may be new to you, because now I am using x in place of angle theta. So don't get perturbed because of that. Now in this table also, at the top, instead of theta had I written x, and instead of sin theta had I written sin x, below down values wouldn't have changed. So whether you use notation x and sin x, or you use theta and sin theta, or you use t and sin t, or u or sin u, that notation is not important. Actually what is important is quantity is written inside the table, right? So don't get perturbed because of the notation. This universal notation I am using here, y equal to sin x, in which x is called independent variable and y is called dependent variable. These are certain terminologies, like what we use in topic functions, that you will be having separate sessions on this particular topic. But I thought I would just use the same names, that x is independent variable. It varies independently. It varies as per your choice, as per your wish. So I allowed theta to vary from 0 to pi by 2, then from pi by 2 to pi. There was no constraint, right? So theta varies independently, means it varies as per our wish. But sin theta gets dependent on the quantity theta. So this is called dependent variable. Okay, so we are actually looking for a relation between theta and sine theta, or I would say x and sine x, means we are interested in drawing graph now. Now that graph is drawn with help of two axes. One is horizontal, other one is vertical. Horizontal one is kept for independent variable, and the dependent one is measured along the vertical one. Okay, so if I want to take care of this table on this graph, then first I will have to mark those points. The distance is pi by 2, pi, 3 pi by 2, 2 pi. These are the angles which I am mentioning here. And then I want to see what happens to values of sine theta. Now sine theta value changes from 0 to 1, means it increases from 0 to 1 when theta changes from 0 to pi by 2. This is my first entry, like in the table says. Now same thing I am trying to put now on graph, that I have like increased that graph, that curve, up to a height at 1 above x-axis. Now when you move on arc BA dash, now theta will go from pi by 2 to pi, it further increases, and sine theta now decreases from 1 to 0. So picture would be something like this. Now when you are on A dash B dash, your theta would increase from pi to 3 pi by 2, and your y coordinate on unit circle changes from 0 to -1, means it decreases 0 to -1. So those are the values of sine theta. So on this particular graph, they would be shown vertically, and graph comes down up to a level -1. Now when you move on B dash A, means theta changes now from 3 pi by 2 to 2 pi, and your y coordinate on unit circle increases from -1 to 0, means your sine theta increases from -1 to 0. So that all is to be shown now here on the graph like this, that now vertical values will increase from -1 to 0, and when the angle matches 2 pi, you are at the horizontal axis. Now this is the story of just that first circle. On that unit circle, what we had seen. Now I want to generalize this, and I try to draw a fresh graph, marking all the points. Some I have taken on the negative side also. That means I am taking those angles which were in the clockwise direction, and then further 2 pi also I have marked some angles, and then I see that you get a wave. So basically graph of sin x is a wave, right? Like how you are seeing in the picture. Now certain things you can learn from this graph. I observe that whatever is the behavior of sine curve between angle minus pi and plus pi, that same behavior you observe between pi and 3 pi. That means between 2 points minus pi and pi, which are at distance 2 pi, you are observing the behavior of sine curve getting repeated afterwards. A periodic function repeats its behavior. So since here I am observing that sine function is repeating its behavior, so I say sine function is a periodic function. This is one thing what you can see from the graph, or you can conclude from the graph. Also, I observe that if it repeats its behavior, then after how much time or how much length it repeats its behavior. Now that repeating behavior mathematically written as sin x equal to sin x plus p. If interval length is p, and if it repeats its behavior, like here in our graph, after interval length 2 pi, if it is repeating its behavior, then in place of p, I can say 2 pi. So smallest p, which is positive, if sin x equal to sin x plus p, then p is called the fundamental period. And if p is not the smallest one, then we will be just naming it as a period, not fundamental period. So basically what we observe here is the way I have shown in the figure, that 2 pi is that length. So we understand that fundamental period of sine function is 2 pi. Now some of you may think that how do you say it is the smallest one only? Now if you break it further, and if you in place of pi, if you see in place of 2 pi, I'm sorry, in place of 2 pi, if you see, had I taken interval length as pi, then function wouldn't have repeated its behavior, right? So pi cannot be the fundamental period, but 2 pi is the fundamental period. Now some of you may draw the picture or the graph further, and you may realize that after interval length 4 pi also function repeats its behavior. But then 4 pi in that case would be called just a period, not fundamental period. So in general, the result can be sine x equal to sine x plus p equal to sine x plus 2p equal to sine x plus 3p and so on. And p is the fundamental period. Now, this is all about the periodicity of the function. Now, periodic function in detail, you will be learning in separate sessions on functions. Certain more observation also you can have from this graph. When x values are from 0 to pi by 2, correspondingly sine values are from 0 to 1. Means sine function is increasing, values of sine are going up, right? So we observe that when angle x increases in 0 to pi by 2, sine x increases. Okay, so such a function is called increasing function. When x values increase, if y values also increase, then function is increasing. So we observe this behavior of sine function in 0 to pi by 2, that it is an increasing function. I have taken just a small interval 0 to pi by 2. If you wish, you can see that in 2 pi to 5 pi by 2 also similar behavior we are observing. That means when x values increase from 2 pi to 5 pi by 2, then y values, means sine values, go up. They go up to 1. So graph is increasing 1. Okay, so we observe that sine function is increasing in 2 pi to 5 pi by 2 also. So actually you should sit, draw graph, and I have drawn only up to 3 pi. You extend the graph and check at in which all intervals function is increasing, in which all intervals function is decreasing. This is actually to be taken as exercise, then only you will have that more clarity. Now I have here just written function is decreasing. Now understand one thing, that like in 5 pi by 2 to 3 pi, values of x are increasing, angle is increasing, but values of y are decreasing. So this would be called the decreasing function. Okay, so function shows increasing and decreasing behavior in various intervals, that needs to be studied. Okay. Now we try to draw graph of y equal to cos x. Here also we will be taking help of unit circle, but I'm not repeating the steps like how we did in case of graph of y equal to sine x. Here I will try to give you directly the graph of y equal to cos x. How does it look like? And to our surprise, this also looks like quite similar to, I would say, the graph of y equal to sine x. This also is a wave like how we found in case of y equal to sine x, but this is a shifted graph. Now, some observations we can make about this graph. And first observation is cos function or cosine function is also a periodic function, like how we saw in case of sine function. And fundamental period of this function is also 2 pi. I am saying fundamental period. Now, larger periods also you could have had like 4 pi, 6 pi, etc. As I mentioned in case of sine function, here also you can have similar thing. And one general result I can write, that cos x equal to cos x plus p equal to cos of x plus 2p equal to cos of x plus 3p, etc., where p is the fundamental period. Now this is about cosine functions periodicity. Now we can also have some more, like about this graph of y equal to cos x. What I observe is that when x increases in 0 to pi by 2, then cos x values decrease. See, now x values increase from 0 to pi by 2, but cos x values are decreasing. That means it is called a decreasing function, right? So cos function in 0 to pi by 2 is a decreasing function. Again, here I have just taken one small interval 0 to pi by 2. You can check for yourself that in which all intervals cos x is increasing, in which intervals cos x is decreasing. Now this way you can study the graph. I always use word read the graph, study the graph. You should be able to make such statements that in which interval function is increasing or it is decreasing or it is becoming flat. Some certain results you can mention with help of graph only. Okay. Now in this way we studied in this particular session graphs of y equal to sine x and y equal to cos x. In next sessions we will be having more graphs on more trigonometric functions. Till then, stay tuned. Thank you.